In this video, I want to help people who are interested in making and selling Agon Lite units with pre-installed firmware with the microSD card already loaded with the demonstrations and test applications that we have. So I want to take you step by step from ordering or from receiving a SMD populated board from your PCB manufacturer, such as PCBWay. And then what you need to know to install the through-hole components and to upload the firmware and the example applications into the microSD card. So what you need for this is, of course, you will need a Windows PC. One of the tools that are required does not have a Mac or a Unix version. Windows 10 will do. You will need an installation of the freely available Arduino IDE. I'm giving you the URL here where you can go and download it. All the URLs will be repeated in the video's description, so it's easy for you to just go there and click on them. You will also need an installation of the equally free ZDS2 IDE or Integrated Development Environment from Zilog. That's the link where you can go and download it for free. You will need, and that's the only hardware thing you will need a Zilog Smart USB Cable. It has this product number I'm showing there, but that's the latest version, and it's almost impossible to find it now. It's not in stock in any of the usual places. But according to the DigiKey website, there is an alternative which has a different product number. I'm showing that as well there. And that alternative is at stock at Mouser, not at DigiKey. Now, I haven't tried that, but looking at the photos, it looks identical to the one I have. So I have no reason to doubt DigiKey that this is an appropriate replacement. And you can just go to the web address that I'm giving you at Mouser, and they have many in stock. It costs $67 if I remember. Of course, you will need SMD populated Agon Lite boards that you will get from your PCB manufacturer. And you will need the through-hole components that are required. They are mostly connectors, also a couple of capacitors, an LDO regulator, and a buzzer. If you have all this, so now we can start. If you are getting a pre-populated Agon board with the SMD components already soldered in from the factory, but you are soldering the through-hole components, which is basically all the connectors, the two decoupling capacitors, and this LDO regulator, plus this pin header here, and a couple of other pin headers inside, and the buzzer. So these are the through-hole components. You can solder them normally. There is nothing special about how to solder them. The only advice I would give is for the audio jack, when you put the jack on the holes on the PCB, there is always a little bit of wiggle room, and I recommend you push it up towards the edge of the board before soldering. So use that wiggle room to push this connector as far in that direction as possible. Same for the reset button here and for the USB jack. Just use the wiggle room to move them towards the edge of the board as far as possible. And the other thing, and this one is important, this one you cannot mistake, is when you install the LDO regulator, there is a metal pad underneath. So you put the regulator through the three holes and then bend it over. You should not use anything in between the LDO and the large metal pad on the board. Do not use any compound, not even thermal compound, nothing. Just clean the pad with IPA, clean the tab of the regulator or the chassis of the regulator with IPA, and make them contact one another. And the reason is the tab of the regulator is at 3.3 volts. And so is the pad on the board. So you want them to electrically contact one another So the 3.3 volt is provided to the board through a large surface area. Now, there is another important thing to notice. On the other side, the copper flood, the copper fill on the back side of the board is at ground potential. But the metal screw or the metal bolt and nut, they will be at 3.3 volts. Again, because the tab is at 3.3 volts. So what you want to do is in between, let me put it this way, in between the nut and the board, you want to put a dielectric or a plastic or a nylon washer to isolate the nut-bolt combination, which is at 3.3 volts, from the copper fill of the board, which is at ground. If you do not use a nylon spacer here, or any dielectric, anything that is electrically insulating, then you will be counting on the solder mask to separate 3.3 volts from ground. And the solder mask is a very thin layer, so you should not do that. Just make sure you use a nylon or a plastic washer on the back side, contacting the board, separating the metal bolt and the metal nut from the board. And usually I use these components here. The bolt that you should use is a 2mm bolt. All holes on the board are 2.5 millimeter. So these are the bolts you should use. It's the same one here. Then immediately on one side of the bolt, you can use a metal washer, just a normal metal washer first. I'm having trouble putting it in there. A normal metal washer first, and then a lock washer. You put it in there. And this combination you put through the hole of the regulator. And in fact, you can see it here. You can see there that there is a normal washer and a lock washer, both made of metal. And then this other side here will poke through here on the other, well, here, but you get my meaning. It will poke through. And then on the other side, the first thing you do is to put the nylon washer or any plastic washer, anything that is electrically insulating. And only then you put the bolt. That's the idea. It's very important that you follow these instructions, not only to prevent short circuit here on the back of the board, but to make sure that the LDO sits tight and flush against the metal pad on the PCB, so they make good electrical contact. And the idea of the lock washer is to make sure that the tension is never lost, that the LDO regulator is always pressing against the board, very flush against the board. That's basically it as far as soldering is concerned. To load the firmware, you can start from my website, click on Agon above. All the links are provided below. And then if you scroll down on the Agon page, that's the main website, you scroll all the way down, and then there will be a link to my GitHub repository. You click on that, and there you are in my repository now. And we will start from the microSD card files. That's the directory in my repository that we need. But the easiest thing to do is to just go back to the main page of the repository and download the entire repository in the form of a zip file like I'm doing there. Now you just download the whole thing. Once it's downloaded, you double click on it to uncompress, to open the zip file. There we go, it's downloaded. So I double click on it, go into that directory, and then you just take the microSD card files directory. That's the one we want. So you copy that and you paste to your working area. In my case, the working area will be on the desktop. the subdirectory will be Agon Light on my desktop. There it is, Agon Light. So it's empty now, so I will just paste the microSD card files directory. They are all there. So now at this point we take a microSD card in its adapter. See, the microSD card itself is tiny. You may need to use an adapter like I'm doing there, connecting it to my main PC. And now we just double click on that microSD card files directory, mark all the contents, copy them, and paste it to the actual card that is connected to the PC. It's empty right now, we paste it, and there we are. That's the first step. We now have a microSD card. We just eject it for safety. Once it's ejected, we can pull it out, remove the microSD card from the adapter, and insert it on the Agon unit itself. There it is, going into the port, the SD card, microSD card port of Agon Light. Now, optional is to connect a keyboard and a display, a VGA display at this point. It allows you to see what's happening. But the important thing is that you connect power, and you connect power using a USB card with a type A connector. The LED will light up. It's difficult to see on the video. There you are. And that's a green LED, believe you or not. So Agon Light is now on and connected to the main PC via USB. So at this point, even in the Agon Light repository itself, there is a link to the next step, which is Quark VDP. Basic, we already put in a microSD card. We don't need to do anything about that. But Quark VDP is a repository. Same thing, you just click on that, download the entire repository in the form of a zip file, unzip it, go in there, mark everything, copy it, and paste it in the working area. And my working area is desktop, subdirectory Agon Light. So paste all those files there. There we go. And the file we need to open now is the video sketch, which is an Arduino file. So we open the Arduino IDE. I'm double clicking on my Arduino IDE icon. It will open with the previous sketch you had open. It doesn't matter what it is. You just go to File, Open, go to your working area, which in my case again is desktop, and then Agon Light. Then you double click on the video sketch. That will open it in Arduino. Arduino will ask you if it can create a new directory called video and move the sketch there. Just click OK, accept that. So that's the sketch now. That's the firmware for the video display processor. It created a new directory, video. So now you have to manually take all the other files and move it to that video directory in your working area. There we go. So now everything is in that video directory. You can now choose the COM port, communications port. It's on the Tools menu and port. In my case, the port is already chosen. The active port is already chosen. These are the correct options. You may want to pause the video here and note them down if you like it. These are the correct options. I'm just showing them to you. And now you just click that arrow to compile the sketch and download the sketch into the ESP32 in the Agon Light unit. And that's what it's doing now. I fast forwarded this. This can take several minutes. I'm fasting this forward. And then the Arduino will reset Agon Light at the end if everything was okay. So now the third step, you can go back to the website and choose Quark MOS. That's yet another repository, also by Dean Belfield. And just like before, you just download the entire repository in the form of a zip file. That's what I'm doing now. Wait for it to complete, and then you unzip it, go in there, mark everything, copy it, and paste it in the working area. So that's the third time we do this. That's the working area. I will create a new directory now just to make everything clean, a new folder. I'll call it MOS. Then I will go in the MOS folder and paste everything there. So that's the MOS, the basic operating system that will be downloaded into the flash memory of the EZ80. That's the project file, MOS ZDS project file. We will open that from within the Zilog ZDS2 integrated development environment. So I double click on the ZDS2 icon on my desktop. There we go, it's being opened. Then you go to the file menu and open project, not file, open project. Now you go to your working area, which in my case again is desktop and Agon Lite. Go into the MOS directory and open the MOS ZDS project file. It will be open now. Next thing to do is go to the build file and rebuild all. It will recompile everything in your own computer. And after that's done, we can download the resulting project into the EZ80 CPU of Agon Lite. 2 warnings, no errors. It's important that you have no errors. You may get a couple of warnings. So now we take the Zilog Smart USB cable that you should have. It has a keyed connector, so it goes in only one way. And we connect it to the ZDI port of Agon Lite. And Agon Lite will automatically be reset the moment you do that. And that little LED on the smart cable will light up. So now we are ready to download MOS into the CPU. We go to the debug menu, and within the pull down of the debug menu, we'll go to download code. Choose that one, and the code will be downloaded into the flash memory embedded in the EZ80 CPU. It takes a little while. This time I'm not speeding this up. This is in real time now. It's programming the flash embedded in the CPU of Agon. Once it has programmed it, it will do a verification pass, so you should watch out for the messages you get on the bottom of the screen. The status messages that you get there, it will tell you whether it was successful. Download complete, it's verifying now. Takes a couple of seconds to verify, and it was successful. That's the message you want to see there. Now, to be double sure, you can go back to the debug pull-down menu and choose verify download, and it will verify it again to make sure that it was downloaded correctly. This is not really needed. It's just if you are paranoid, you want to make sure. I wanted to show you how to do it. And once again, it is successful. So now we are done. So we can go to the debug menu again, pull it down and choose stop debugging. So now the IDE is disconnected from Agon. You can close that window and you can go back to your Agon unit and remove the smart USB cable from the ZDI port. After you do that, you have to press the reset button there on that corner. That will reset Agon, and once it boots up again, it will have all the firmware properly loaded. And if you did it correctly, this is what you should see. That's the screen you would get. So now you can functionally test Agon. You can start with *cat for catalog and list the contents of the microSD file that we've just loaded a minute ago. You can load one of them like triangles.bbc, which is a basic program. We can clear the screen with CLS and then list the contents that we just uploaded. That will create triangles on the screen. So you can type run, and this is what you should see. Random colorful triangles on the screen. So if you see this, everything's probably working. You can press ESC to escape, clear the screen, go back to mode 1 so you can see things better. List the catalog again with *cat, choose another program and load it, like load cube.bbc. That's the one I recommend. Clear the screen, list it to make sure everything's correct, and now we can run it. And once you run it, it will ask you 2 questions. I suggest you choose S for a solid cube and mode 0 for the highest resolution mode. And then it will draw a rotating 3-dimensional cube on the screen. If you see this one, then again, you can feel reassured that everything is working fine. There is only one more thing that we need to test. We need to test sound. So we press ESC to escape, go back to mode 1, so the characters are a little bigger. List the catalog again with *cat. And now we load the sound program to test the sound. Load sound.bbc. We can list it, it's a short program. And when we press run, this is what you should hear. You press ESC to quit the program, and now we are ready to put Agon in its case. Now to do that, we need these 3 components. We need the Agon Lite unit itself with all the firmware loaded and a microSD card loaded. We need the 2 halves of the 3D printed case. There are links to all this in the description. And we need 4 screws. M2 screws, either 16 or 20 millimeters long. They should be self-tapping, but the diameter is 2 millimeters. So M2 times 16 or M2 times 20, 4 of them. Then you take the Agon Lite board and you put it on the bottom half of the case. It will fit very snugly. Make sure that the 4 holes are aligned. They will almost inevitably be aligned. If you place the board inside, everything will self-align almost. Then you put the top half of the board on top. Make sure everything lines up correctly, as I am showing now. And everything lines up. So you flip it upside down, and you just screw down the 4 self-tapping screws with 2 millimeter diameter using a little screwdriver. Couldn't be simpler than this, could it? So there you have it. That's your Agon Lite unit, loaded, tested, encased, and ready to go. I hope you've enjoyed this. Take care and good luck.